Okay, let's get started for our session today. Lecture number 2, week number 4. We are looking at some basic concepts related to objects and classes. So we will be continuing our discussion from the previous session, right? So far, you know how to create a class, how you can create different objects of a class, an array of objects, a pointer to object. Then within the class, we have seen you can have data as well as functions. Then you had seen a special function, which is constructor, which is generally used to initialize the data members, right? And we had also seen in previous discussion a scope resolution operator, which we use when we are giving the definition of the function outside the class, right? So today we'll be continuing that discussion. So before we see some new concepts, in your lecture slides, there's an example, a different example than what we have been doing in our detailed discussion, where you are required to create a class which can model a temperature. Temperature has a magnitude, right? And it has a scale that whether you measure it in Fahrenheit or Celsius. So maybe you can go through this example. Every single function is explained in detail. There's no new concept, right? You can say the implementation of the same concepts which you know, but with a different example, right? So you can go through this example, and if you find any problems, you can tell me in the next class so that we can discuss them, right? So let's start with our topics for today. So we were looking at constructor, but there are still a few points which are related to constructor which we have not discussed yet, right? So let's do them today. So to start with, again, I'll be using the same class which we have been using since day one. So we'll just be discussing some ideas with our point class, right? Okay, so again, I'll not be repeating everything, right? You can assume that the functions are there. I'll only be focusing on the things uh, which are related to our discussion for this topic, okay? So you have some functions or anything that you like, right? Okay, so you have already seen that in a class, normally we always make a constructor, right? For example, you have seen this constructor that you assign some default values, and then you also have a, you can say, parameterized constructor in which you can pass some values, right? So let me quickly write it and then we see. X gets a value A, Y gets a value B. Okay, so you see, constructor is something that is so frequent, although it is not a compulsion that you must make a constructor, but naturally, whenever you write a class, you will always be making a constructor, right? Because we always need a mechanism through which we can assign values to our data members, right? So for a constructor, you have this, you can say, conventional syntax available where you can use the assignment operator to give values to the data members, right? So this is, you can say, the conventional way where you use the assignment operator, and whatever value you want to give, you can give it to the data members, right? Since it is something very, very frequent, so there is an alternate syntax of the constructor as well, right? That instead of using the assignment operator, there is another syntax, right? It will have the same effect, nothing different, but only the syntax is different, right? So I'll just explain to you. In the beginning, if you find it difficult, you can stick to the conventional syntax, but later I would appreciate if you can migrate to the, you can say, other syntax, which is more common. So what you do is that after this function header here, you put a colon. Okay, this is a single colon, right? Not the double colon, which is scope resolution operator. And then see carefully what I do. I write X, and within the parentheses, I write the value which I want to give to X. Okay, so what does it mean? It simply means copy this 0 into X. So it is actually same as this statement. X is assigned 0. And now actually you don't need to write this statement here, because whatever we wanted to achieve, we have already achieved through this. Similarly, we also want to give a value to Y. So you write Y here. Within parentheses, whatever value you want to give to Y, you can write here. And since we have done that, so I don't need anything here. So in that case, you see the body of the constructor is actually empty. Okay, we don't have anything here because You can leave it empty. There is no harm in that. Whatever you wanted to achieve, you have already done that through this syntax. Okay, it is exactly the same impact, but just a different syntax. Now you can apply the same concept to a parameterized constructor, right? So what you do, we put a single colon here. Okay, again, single colon, not double colon. Please be careful. Then in X, we want the value A. So you write X, parenthesis A. This is exactly same as writing this. Okay, but this particular syntax, you can only use with the constructor, not anywhere else, right? You cannot use this syntax just like a statement anywhere else. It is only for the constructor that you can do that. Then you put a comma because we also want to assign a value to y. So you say y gets a value b. And now once you have this, you can actually get rid of these two. Okay, so you see nothing new. It's exactly the same thing, but just you can say a different syntax of achieving things, right? Now, since we are discussing constructor, so let me just quickly tell you one last thing related to constructor before we move ahead. You see, it is common that we have more than one constructor in our class, right? So as we discussed yesterday, this is a no argument constructor, which is not taking any input. And this one is a parameterized constructor, right? Because it is taking two inputs, which we are copying in the data members X and Y. When you create an object, you actually take a decision which of these constructors you want to call. If you know the initial values, you can call the parameterized constructor. Else, you just write point P and the default constructor is invoked, right? So instead of making multiple constructors, when we were in week number 2 and we were doing a recap of functions, we saw something which is called function with default arguments, right? If you remember, function with default arguments. So when we were doing this discussion, we actually observed that function with default arguments is actually very similar to function overloading, right? That instead of making different versions of a function, you give default values within a single function, and it actually behaves very much similar to what we achieve with function overloading, right? So now we'll be applying the same concept to constructor, right? That instead of making two different constructors, what we'll do, we'll just make a one single constructor, but we'll have some default values within the constructor, and it will actually behave like overloaded constructors, right? So let me just write it and then we discuss it. Okay. So here what we do, we make the constructor name of the function, and here I can write int a and I give a default value, and int b I also give a default value. And within the body, you can write in the body, you can also put a colon here and right there. As we discussed, we are writing x is a and y gets the value b. Okay, now let's discuss that in the main. When we create an object, what are the different possibilities we have? So maybe we are write our main in this part. Okay, now you see I can write point p1. Now what will happen? Since I did not provide any value, both the default values are used. So in P1, I will have 0, 0. I can also write point P2 and I can pass only one value. When I pass only one value, this value actually goes to A. Okay, so it means X will get this value. And since I did not provide the second value is the default value, which is 0. So what happens is that in P2, X gets the value which you have passed and Y gets the default value. And there's a third possibility that I can also write point P3 where I pass both the values. When I pass both the values, A gets the value 2 and B gets the value 3. So none of the default values is used, and I will have a situation like this. So now you see, actually we have written only one constructor in the class, right? But since we are using default argument, So this is not one constructor. Basically, we can call this constructor in three different ways: with no arguments, which was the first example, right, where you don't have any arguments; with only one argument; and with two arguments. So this is like you have overloaded the constructor, but rather than using three different versions, a single version is doing, which is a strong, you can say, aspect of when you write functions with default arguments. Now let me quickly add this constructor to our class, and then maybe we can discuss, right? So this is the class that we have been working with previously. So now what I will do, I will get rid of these constructors, and I will make one single constructor, say point int a is 0 and b is also 0. And then within the body, we do the same thing. X gets a value a, y gets a value b. Okay, and in the main, now what we do, we create three different objects of point class, and every time we call a different constructor. Okay, now you see, we have the possibility of calling any of the constructors. When I use this statement, we are using the default values. When you are using this, the x is 2 and the y is default. And when you are using the third constructor, both the values which you have used, they are passed. So you can actually also call the print method of each of these, and you can convince yourself that the objects have the values which you have expected, right? So okay, now we'll be adding some more functionality to our class. Basically, you see so far, all the functions or constructor that you have seen in a class, this is something that you will make in almost every class, right? In every class, you will make a constructor. In every class, you will make a print function. In every class, you will have a function to set values, right? So far, you must be wondering that we have not done anything useful, right? We have not solved a problem. And the reason is that we are gradually going towards that, right? So whatever concepts we have seen so far, including what I'm going to tell you now, these are the key components which we expect every class to have, right? And after that, we actually add some other functionality, right? For example, if you are making a class for a student, so we expect to have some data. We expect a display function. We expect a constructor, maybe overloaded constructor. And once we have all of these ingredients present, then maybe we can add some other functions like calculate GPA or summary of attendance, something like that, right? So among these key ingredients, another important ingredient that we'll see is basically what we call set and get functions or methods, whatever you want to call them, right? Set or get methods or functions, whatever you call them. Okay. Now, what are these and why do we need them? Okay. So in order to first understand why we need them, let's say you have some class. Okay. Maybe there's a class student and you make an object of class student, say student S. What is the data of the student? Say ID, GPA, maybe cell number, address. Okay, this is all the data of the student. And then you will have some functions like print or other functions within this class. Okay. Now, suppose in student class, I need the GPA of a student. Okay. So you see, I cannot do like this. This is not allowed because it is private data, and we discuss why we have data, we keep data private. We have a print function, but maybe printing is not something that you will always do. Maybe you need to do something else, right? Maybe you need to find the grade of the student, so you will need its GPA in the main, right? And there can be another scenario that suppose instead of single student, I have an array of 10 students. Okay, maybe I have say 20 students in my class. So all the students have some GPA, and in the main we say, okay, what is the average GPA of this class? Okay, suppose there is a query, someone asks me, okay, you are teaching this, so tell me what is the average GPA of BSCS2A. So in order to answer this question, you see, I cannot make a function inside the class because one object only has its own GPA. So it means I will have to do those computations in the main or in some other function, right? So it means I need to access this GPA in the main, right? So for that, since we cannot directly use the dot operator to access data or to read data, we'll be making something which is called get function. So get functions are actually for reading data in the main or at some other place where access is not allowed, right? When I make them, it will become clear. But for the time being, you can think of get functions as you can say reading data. Okay, now let's see the justification of what are set functions, okay, and why do we need them. Okay, again, suppose we have a student object, maybe S. When the student was admitted to the university, we set all the values, say ID, number, address, email, okay, and GPA was set to a default value of 0 because at the time of admission there was no GPA, right? So we set it to a default value. Now, after the first semester, every student will have some GPA, okay? So it means we need to change the GPA of a student, right? And again, I cannot do like this. Maybe this I cannot do because it is private, right? Constructor I cannot call because the constructor was called when the object was created. You can say, okay, we already have a set function in which we pass everything and we can set data. You see, yes, this will do the job. But there's a problem with this. If I have a set function, which is taking maybe 1, 2, 3, 4 inputs, then you see address of the student has not changed. Enrollment number has not changed. Phone number has not changed. Only one field is changed. So if only one field is changed, it means only GPA would be different. Rest everything is exactly the same, which I will be passing to this function again. So rather than this, I should have a function in which I can only set the GPA of a student, right? Another example could be that suppose you have a class for flight, right? Flight has a lot of data like date, time, okay, and destination and many other things. Suppose a flight is delayed. So when a flight is delayed, you need to change the time of departure. Rest everything stays the same. So there is no need to again, you can say pass all the arguments which are unchanged just because you want to change one single value. There should be a smart way of doing that. Okay, so for that, we have these set functions for every data member, which are like write functions, which can update your data. Right, so get functions will be for reading data, write functions are for updating data, right? So let me now show you these functions for the point class so that we understand how they work and why they are useful and why the set function or the constructor we previously made is not appropriate for this scenario. Okay, so let me just again, you can say, go back to this class. So like always, we have two data members, X and Y. Okay, to save space, I am defining the variables in a single line, but please, when you do that, you just use one line for one variable, okay? Okay, so we have constructor, I'm not writing it again, okay? We had maybe set function, I will write it so that you can compare it with the set functions we are writing now. That how is it different from what we'll be doing now. So X is A and Y is B. Okay, now what you have to do for every data member, you will make a dedicated set function. How many data members we have? 2, X and Y. So I will make a function to set the value of X, which I can call, say, set X. And it has a very standard, you can say, syntax. You simply have one assignment operation and that's it. So this is the function if you only want to change the value of X. Similarly, you can have a function Y, set Y. And within the body, you again have this statement, which is changing the value of Y. So you see, this is like an update function. Whenever you want to change the value of only X and not Y, you can call set X. If you want to change the value of Y without changing the value of X, you can call the set Y function. So we had 2 data members, we have 2 set function. If you have 10 data members, you should make 10 set functions. Again, This is not a requirement. Your program will work perfectly fine without these. But once you are writing a program, at some point in time, you will be needing these functions. Okay, maybe at this point in time, you think that they are not very important. Yes, for the examples we are doing not, but once you will be writing some relatively bigger programs, you will badly need such set functions, right? Now, just like set function, we will now have a get function for each of the data members. Again, get has a very standard way. Get function will return you value. So you can make a function get x, and you will have one single statement in such function like return x. Okay. Similarly, you can have a function get y. So I write integer get y, and here you have a single statement return y. So you see all the get functions, you can give them any name, but just to be meaningful, I am calling them get x, get y, right? This is not keyword, this is just any name you can give, but it makes sense to call them get x, get y. So get function will have one single statement, return and the variable you want to get, right? So I have a get x function in which I have written return x. I can have a get y function in which we have written y. And then you can have other functions in the class. Now, what is the advantage? That suppose in the main, if I create a point p which is 2 3, then I have some program and later I want to change x, right? So rather than calling set, right, in which I change x to 4 and I keep y same, so I can, if I only want to change x, I will write set x and the new value. So what will happen? This 4 will go to a, and from a it will go to x. So you see, maybe in this example, we don't realize the importance or the usefulness of these dedicated set functions, but just imagine your student profile and the student object. You will have so many attributes. Okay, and after every semester, we only need to update your GPA. Okay, nothing else is updated. We only need to, your address, your name, your enrollment number stays the same. So it would be very handy if we can say set GPA and we can pass your new GPA to this function rather than passing everything again and again, which would be very inefficient, right? So let me quickly add these functions and enrich our point class. Okay, so this is the point class again. So what I will do, I will simply make two set functions and two get functions, right? I write void set x int a, in which I just have one assignment operation, void set y int a. So y gets the value a. So these are the two set functions. Now I have to get function int get x, return x. That's it. Int get y, return y. Okay, now let's see, for example, in the main, I create an object of class point. Okay, and say p, which is 2 4. Now, if I only want to change x, so maybe I can write point dot set x, which is also 4. So now the point becomes 4 4. And in the main, suppose someone asks you add x and y component together and show me the answer. Okay, so how can we do that? So you see, now we have the get function. Since the data is private, so if it was not private, we could have done this. Okay, if it was structure, we could simply do this. But you see, if I'm trying to do this in class, if I take the cursor here, so it is giving me an error that x is inaccessible. Why it is inaccessible? Because it is private, and we know that with dot operator, we can only access things which are public. So wherever you want to write p dot x, what you will do? You will write p dot get x. Now you see p dot get y. Now you have a mechanism to have the values of, you can say indirectly having values of the data members through these public functions. And now if you want to display the answer, you can actually display it. So we are actually trying to add the x and y components together. And the key, you can say, to this program is this one, right? Maybe set function we have already discussed. So you see, these are the two get functions. When I need the x component, so it was 4, so I get 4 here because return x, it will give me back the value of x. P dot get y, return y, it is giving me the value of y. So it will be like 4 plus 4, which is 8, which gets into this variable answer, and we can access it, right? So this is just an example to show you. Of course, adding x and y component is not very useful, but the idea is that when you want access to data which is private, you cannot use dot operator, but you can make get function and you can have that data, because maybe you want to use that data in some formula or in some other expression, or you want to pass it to some other function. So conclusion is that these get and set functions are very handy, and whenever you are making a program, it's a good idea that you always make these get and set function in your class, right? So with that, maybe we can have a discussion if you have any queries. Okay, next we have you can say a very minor concept, right? So I'll just be explaining it directly from the slide, which is related to the scope, right? Maybe this situation will never arise, because when you are declaring variables, you will be choosing some meaningful names, right? But just in case, you see, there can be a situation where you have variables having the same name, right? So let me just show you an example, and then I explain, right? So we have a class and you have int x. This is the class data member, right? So in the constructor, we are giving a value 5 to this data member. Okay. Now we have a function in the class. Okay. In the function, we again take a local variable which also has the same name x, right? So this is actually the local variable of this function. Okay. Now there can be some confusion that when you write cout x, whether we are talking about this x which is local, or we are talking about the x which is the class data member, right? So this just although of course you should avoid repeating the same variable name, but just in case if there's a situation like this, so from your knowledge of programming, you must be knowing that whenever we use a variable in a statement, it refers to its nearest declaration, right? So actually, when you are writing x, the nearest declaration is this one, which is the local variable. So it will actually be printing 1. Okay. And if you want to access the data member x, which is the member of the class, right, then you can use there are different ways, but we have seen only one way for the timing, which is the scope resolution operator. If you remember, we discussed it yesterday and we said this is actually belongs to. Okay, so if there's confusion, you can avoid this confusion by using this scope resolution operator, name of the class, right? Then you have this operator, and then you have this variable. So it is saying variable x, which belongs to class test. Okay, so it means that the first statement will print 1 and this statement will print 5, because here we are talking about the variable which belongs to the class. Okay, so when there's a confusion, you have variables with the same name, you can use scope resolution operator to tell that when you need the class variable and when you need the local variable. Although you should actually avoid this situation, right? It is not a good idea to have same variable name, because practically, of course, when you will be defining variables, it will not be ABC or XYZ. They will be more meaningful, like address, name, ID, whatever they are referring to, right? So this was just a small concept. So I hope there should not be any problem in this one. Let me see if there are further queries before we move ahead. Okay, now we'll be looking at again something that we'll be using frequently. To some extent, you must have seen it in your first course, but nevertheless, we'll quickly have a look at it again, which is called dynamic memory allocation, right? You can use it normally, you use it with arrays, right? But the discussion we'll do today, it is not focused on arrays, right? We'll be talking about just single variable, right? So first as we always do, first I will give you an example from basic data type, that is integers, right? Because it is easy to understand concepts from basic data type. And then we will replicate the same ideas to objects of our classes, right? So let's start our discussion. And for some time, let's forget about classes. Just think that you are writing a structured program in which you have just integers, floats, characters, basic data types, right? So let me just write a very simple program. which we have written many times when we were doing pointers, right? So suppose this is A, which is 5, and then we have discussed many times you can take a pointer. P is a pointer to integer. P will hold address of an integer. So it means you can write like P gets the address of A. And now if you want value of A, instead of writing say cout A, which gives you the value of A, you can also write something like cout this contents of or dereferencing operator, which would be the same thing, right? And when we are doing this, we always see for our own understanding that how things are actually happening. So you see maybe this is your A, which is 5. Say it has address, which is just assume any number 7,000. And then this is your P. So when you write this statement, P gets the address of A, right? So maybe this one. So what happens? The address of A will go to P. And when you write this, so this is like contents of 7,000. So contents of 7,000 are actually 5. That's why both of these are giving you 5 as an output, right? So this is something we already know. Now let's extend this discussion further, that you see now there are two ways you can access the value of A. One is by directly using the variable A, and the other is using the pointer static P, right? So we also discussed many times that both of these are actually equivalent. You can write A, which means 5. You can write static P, which also means 5, right? So we say, okay, why then I should have two different variables? Okay, why I can't do only with one variable? Previously, we have been doing only with A, that there's no need of a pointer. If we don't need it, we can just use the variable A and we can do the job. But now let's see it from a different perspective, that what if we only keep P and no A, right? That we have a pointer, but we don't want an additional variable, right? So for that, what we do is that I don't want this A, right? I just want a pointer in my program, and I want to be able to store some integer in that pointer, right? So what in such situations, what you can do is we can use something which is called dynamic memory allocation. For dynamic memory allocation, we'll be using a keyword which is called new. Okay. Now, what does this keyword do? New is basically requesting the program for memory. Okay, that you are telling your program, I need memory to store something, and after new, okay, you need to tell what you want to store. What do we want to store? Suppose we want to store an integer. So I will write new int, which is a request. What is that request? I need memory to store an integer. Okay, so new int is basically requesting the program, I need memory to store an integer, and we know integer takes 4 bytes. So what will happen is somewhere in the memory, the program accepting your request will reserve 4 bytes for you. Okay, suppose these 4 bytes are reserved, okay, and the address is say 6,000. Now there is no variable name associated with this location like A or X, right? 4 bytes are reserved for you. Okay, but when we reserve something, we should know where it has been reserved. Okay, if you reserve a room in a guest house, so you need the address so that you can arrive there. Similarly, when you make a request, it will reserve 4 bytes for you, and it will return the address of those 4 bytes to you so that you can store it. And whenever we have an address, where do we store it? We store it in a pointer. So on the left side, I can write P. So now you see, when you write new int, it will reserve 4 bytes for you. It will give you back the address of those 4 bytes which have been reserved for you. It makes sense that I must store that address. Only then it is useful. And we have already seen in detail that you store address in a pointer. So on the left side, I write P. So what actually happens at the back end with this statement, there is some P, and P will have this address 6,000. Now you see this is very much similar to what we did previously, but the only difference is that previously we first had an integer a, and then we use the address of operator to get the address of a. Now we don't have anything like that. We are directly requesting the program to reserve 4 bytes for us. It is doing that, giving us the address, and we are storing that address in a variable which we are calling p, and we already know that that variable has to be a pointer. Now, if you want to give some value to this, you already know you can do like this. So this location will get value 10. Contents of 6000 will get value 10. You can give the value using an assignment operator, or you can sin or anything else, right? So you see now you have a location which is anonymous. Anonymous means it does not have any name. You have the address, but there is no name of this variable, right? But since we have the address, so we can actually indirectly treat it just like we treat an integer. Okay, this is an integer. You can do anything you like with this, but the only thing is that in dynamic memory allocation, you don't have a name for this particular location, right? So this was the discussion with an integer, but actually we want to do the same discussion for objects of classes, right? That instead of having, you can say directly just variable names, we need to have something, a similar thing for the objects, right? So let me just quickly do that. Okay. So now you see it's fairly simple. You exactly as I tell you, what is the syntax on the left side? Data type, static, and some variable. So if you have data type which is point, so instead of int I'm writing point, then I have exactly the same syntax. Okay, so now you can compare the left side and the right side, and you see they are very much similar. Okay, what I have highlighted on the left and the right, only the data type has changed. And maybe next you can write p is, here we were writing new int. We don't need a new integer. We want a new point. So this will create a point object by calling its default constructor. If you want some other constructor to be called, then you can simply, just like you have done previously, you can call the parameterized constructor like this. Okay, so it's your choice. You can call parameterized constructor. If you don't want to call the parameterized constructor, just put a semicolon, and the default constructor will be called just like this. And now if you want to call some functions of this class, okay, we already know that there are two ways you can call this function. One is you can call the function like this, static and dot, and the other syntax is that you can call the function with an arrow operator. Both of these, as we discussed yesterday, they are exactly the same thing, right? But important thing is that with pointer, you don't write p dot, right? Dot operator you use with only an object. So either you write static p and then dot, or you use this arrow operator. One last important comment before we discuss your queries is that you see whenever you are doing dynamic memory allocation, whenever you are using the keyword new, since you are explicitly requesting for the memory, you must also free that memory once the job is done, right? Means whenever you don't need this location anymore, so whenever you are using the keyword new, you must also use the keyword which is called delete, right? Now what does delete do? There were 4 bytes which were reserved for you. You played with it, you did what you want to do. Now the job is done, so it's your responsibility that now you should free this memory. Okay, and the way to free this memory is the keyword delete. You write delete and then the name of the pointer in which you are actually storing the address of that location, right? And let me just write it here as well. Okay, now one last comment, that you see the programs that you are writing, they are not very you can say they are not running all the time, right? So in these programs, even if you are not using the keyword delete, nothing will happen, because when your program terminates, all the memory is automatically released, right? When the main terminates, all the memory is gone. But just take an example of a software which is running on an ATM machine. Now this software is running all the time, okay? And of course, this machine has some memory. just suppose, okay, this is not exactly how things happen, but just to explain you, suppose someone has written a program in which whenever there is a transaction, they use keyword new and then they do a transaction, but they do not use this keyword delete. Okay, it is not written. So what happens is that whenever there is a transaction, you are getting hold of memory and you are not releasing it. So there will be a time, because this program is continuously running, you are never stopping it. So there is a time when all the memory is exhausted, right? There is no more memory. So what happens is that this software will actually crash. So you see, that's why it's a good, you can say, recommendation that whenever we use the keyword new, we should always use the keyword delete. Maybe in the programs that you are writing in the class or lab, it will make no difference, because when the program is terminated, all the memory is free. Okay, but just think of program which keep on executing all the time. So in those cases, if you are using new but not using delete, so that is actually what we call a memory leak, that your memory is slowly and gradually exhausting, and there can be a situation when you run out of memory, right? So you should always use delete when you are using new. And maybe dynamic memory allocation does not seem very effective with these examples, but it is very useful when we are dealing with arrays, right? So maybe at a later stage when we see arrays, so the usefulness of dynamic memory allocation would be better explained, right? Okay, now in the next 10 minutes, we'll be doing some discussion, which is what not very technical, right? But it will help you in writing the program. So we discussed it yesterday as well, that it's a good idea that you split your program into multiple files, right? And today I'll be showing you how to do that in the Visual Studio, right? You can do it manually as well, or if you are using any other IDE, you can do that as well. So ideally, this is a lab task, right? But just for my own satisfaction, I'll be covering it here as well. So basically, if you remember, we said that whenever we are making a class, it is not a good idea to give definition of function inside the class. Okay. So yesterday, what we did was we said, okay, you have a class in which you only have data and function prototypes, and function definitions are outside the class. Okay, so maybe when we created a class, say some class A, we have in private data, and then in public we just have definitions of the function like void f and semicolon, nothing else, and something like this. And then outside the class we provided the definition or the body of each function. Okay, with scope resolution operator, right? For example, just to recall you, it was something like void name of the class, scope resolution, name of the function, and then you provide the body. Okay, now you see, it's good. We have a crisp class definition and function bodies are outside the class, but we want to make it even better. And what we discussed was that normally what you will do is that the data and function prototype, means this part, we will keep in a separate file, which will be a header file .h, and all the function definitions we'll keep in a separate file, which would be a CPP file. How to do that, I'll show you in a while, but let me just conceptually tell you. So for example, if we have a point class, we'll make a file point.h and point.cpp. Here you will have only data and function prototypes. In this you will have the definition of all the function. And once you have to write the main, it will actually be a separate file in which you can include this header file, and then you can create the object. This is your main.cpp or driver or whatever you want to call it, right? So the idea is that for every class you will have two files. It means if I have three classes, for the time being, all the programs you have seen, we make only one single class, right? But in the subsequent weeks, we'll be making programs in which there will be multiple files, right? So it means if I have, say, three classes in my program, say faculty, student, and admin, so right? So For every class, I will have two separate files. Then and one single main. Okay, and how to do that? Let me just show you in the Visual Studio. And I would appreciate that if in the future labs you make it a habit. Okay, so what we do is that, let me just clear it. Okay, so let me just get rid of everything in the main. Yeah, so this is suppose our main driver CPP file. Okay, now once you have to make a class, rather than making it in the same file, you actually go to the project, you right click it, okay, and you will see an option add. Okay, and within add you see an option to add a class. Okay, you can just right click the project, add, and within add you tell you want to add a class. Once you click on class, okay, it will give you an option of a C++ class because we are making a C++ program. So it will ask you for the name of the class. Okay, so I write point. Now you see when I write the class name point, it automatically is suggesting me a header file and a CPP file, point.h and point.cpp. You can ignore rest of the things. And when you click on finish, now you see this is my original file. Now two additional files are created. Point.h, in which there is a class point. It has automatically created constructors for me, right? They are auto-generated. I can just get rid of them. And point.cpp, where you can write the body of the function. Okay, these are blank. I have just removed whatever it was generated. So now what you can do, you can fill this. For example, I can write int x, int y, and here you can write, say, void print, but just the prototype. Okay, nothing else. No body of the function. This is in the .h file. In the .cpp file, you can give the definition of the function. Right? For example, if we have void print function, so I can give its definition like cout x, cout y, and so on, right? So you can do it for every function. And when you go to the program where you will have your main, if you want to make objects of class point, for example, say point p, so now you see it is giving an error. Why it is giving an error? Because it does not know what is point. It says point is undefined. So what you will need to do, you will need to include that header file, which is point.h. Okay, and now you see when I include that file, the error is gone. Normally, you must have noticed that IOStream we are surrounding in angle brackets and point.h we are surrounding in double quotes, right? So when we make our own header file, we put double quotes, so it will search for this header file in the current directory, right? For angle brackets, it means it is a pre-installed header file, right? So that's why we put double quotes for our own header file, right? So now you see it's exactly the same thing. The whatever you put in these, it will be exactly the same, but now your program is better organized. Now you have, when you will have multiple classes, for every class you will have a dedicated header file, dedicated CPP file. And as I told you yesterday, there is a secondary advantage of this as well. Maybe you will not be doing that in this semester, but later on at some point in time, if you want to make a product and or an API, so to your client, you only give the header file, you don't give the CPP file, right? And the implementation you can give as a DLL or a lib file, which is not readable. So if you don't want to provide the code of a class or the functionality of the class, you can only achieve it if you have split it in a separate file, right? If the body is in the same file, you cannot split it, right? So this is something you can say a minor note that in future I would recommend that when you are making some classes, it's a good idea that instead of putting everything in a single file, you split your program into multiple files. Okay, now we'll be moving to hopefully the last topic for today. It is not very frequently used. Maybe when you are solving some practical problem, it is not something that you will be using it very frequently, right? But still, it is something that might be useful in some special scenarios. So let's just discuss that. So this is basically static data and static functions. Okay, so in order to understand this, what we'll do, we'll take an example, right? But this time, not a very, you can say an example that you can correlate with some object in the real world. But just for illustration purposes, I will just taking a hypothetical class, right? So that we can explain this concept. Let me just take any class. I'm calling it test. Okay, and I'll take just one data member in this class, which is one single integer, which we call x. Okay, and here I'll just make maybe for the timing I will make a get function. Okay, and then I will add something to this class later, but before that, suppose there's also a constructor in the class which I have not written, but you can assume it's there. Okay, because it is pretty standard. So let's just see what we do in the main. So suppose there's a parameterized constructor. So I have test t1 in which I pass 5. Okay, there's another object test t2 in which I pass 10. So from our discussion so far, we know that whenever you create an object, suppose this is t1, it has one data member x, it will get value 5. Similarly, you have another object which is t2, it is getting value 10. Okay. Now we have been discussing that every time you create an object, every object has a separate copy of data, right? In other words, T1 has its own X, T2 has its own X. Just like we say, if I have a student class and there is a data member which is GPA, so every student will have its own GPA, right? Means there are separate 4 bytes for every student in which the GPA is stored, right? This is what we already know. Okay. Now, suppose there is a situation, and as I told you, this is not very frequent, but since it is a concept, so let's discuss it. Suppose we don't actually want this. We don't want a separate copy of X for T1 and T2, but what we want is that there is one shared memory location, shared, which is shared by all the objects of this class, say T1, T2, T3, and so on. When we say shared, what does it mean? Suppose initial value was 5. Okay. T3 changes the value of x, so the same x will become 50 if T3 multiplies it by 10. When T2 changes the value to 500, the same location is modified, right? So what we are trying to say that normally if we have two objects, every object has its own copy of data. Okay, this is what happens under the normal scenario, which we have been doing, you can say, since the very beginning. For example, now, instead of this, if we want, we can have a situation where there is only a shared or a single variable, which is shared by all the objects, right? So presently, we are doing the first or the scenario which I have drawn on the top, that every object has a separate copy of data, right? If you want this, what we do, we make data static in our class, okay? And how to do that? The syntax is slightly, you can say, catchy in the beginning, but when you use it, you will get used to it, right? So then let me just gain some space, and then I tell you how you can have static data in your class. And when you have static data, that data is actually shared by all the objects of a class. Okay, so, okay, let me come here. So what you do is that int x, before that you use the keyword static. this is one thing. This is simple, okay? If you want to make something static, I will show you the impact later on, right? But just first see the syntax that if you want to make something static, we just say, okay, just give use the keyword static, and rest of the syntax stays the same. But I'm not sure if you have seen static previously, but I'll just explain. When you have a static variable in your program, you have to initialize it when you declare it, right? For example, if you are not doing objects and classes, you are doing structured programming. Even in those, you can use static data. But a compulsion is that whenever you have something static, say static int a, it's not like that you leave it like this and later you say a is 10. Okay, this will not compile. Whenever you have something static, you have to assign it a value when you are defining it. It means you have to give it a value like this. This is in structured programming, right? The same rule is applicable here, that whenever we are defining a static variable, we need to initialize it as well. But there's a problem, right? In classes, you cannot assign value like this within the body of the class, right? So that's why, but on the other hand, we know that since it is a static variable, we need to give it a value before we can create the objects of this class, right? So a way around which is suggested in the syntax is that outside the class body here, as soon as you have given the definition of the class, here you give an initial value to this variable before creating the objects of this class. How do we do that? You write int, okay. You see, if I only write int x is 10 or x is 10, then there is no way of telling that this is the x which belongs to class test. So you can already guess that we have seen already something which is called a scope resolution operator, which we can use to tell that we are initializing the value of the variable x which belongs to class test, right? This is a key, you can say, statement, which I understand is slightly tricky because maybe you are not familiar with such syntax, but for the time being, just bear with it. When you do some practice, it will become trivial for you, that when we are using static data in the class, we have to give it an initial value before we can actually create objects of that class. Since we are not allowed to give it a value in the body of the class, so what we do is, as soon as the class concludes, we initialize it with some value. In this example, I have initialized it with 0, but of course you can initialize it with any other value, right? Now let me just complete it, and then we can discuss. I will just make a constructor in this class, but a slightly different constructor. So what I will do is just to illustrate you something. So this is the constructor, okay? And here I am saying x plus plus. Why I'm doing this, it will become clear when I actually write the main, okay? Because we want to actually discuss something, that how it is behaving different with respect to what we already know. Okay, let's keep the class till there, okay? Now you see we have an x which is shared. So I just write x. It is not linked with any object and it is initialized with 0 before any object is created. Now in the main, what we do, we create an object test t1. Now when you do that, what should happen? We know that whenever you create an object, the constructor is called. Okay, so when the constructor is called, we go to the constructor, and in the constructor it says increment the value of x, right? So when the constructor is called, it is saying increment x. So what will happen? This x which was 0, it will actually be incremented and it will become 1. Now I create another object of this class, test t2. So again the constructor is called and it is saying increment x. Now it is the same x which is incremented because it is shared by all the objects. So now it will become 2. And suppose I say another object as 3. So since it is a static data member which is shared by everyone, so now this 2 will actually become 3. So you see, every time you create an object, just to tell you or just to convince you that the same location is being shared, we have incremented x so that we see the updated value. Now, if you want to convince yourself that it is actually the same variable, you write cout t1 dot get x. Okay, similarly you write c out t2 dot get x and t3 dot get x. Now you see, when you are calling the get x function, you have a statement return x. Which x? This x. So when you call this function, you see the value which is 3. When you call this function with t2, you again see the value 3. And when you call this function with t3, you again see the value 3, which is very different from how things were happening when the data was not static, right? So now you see there is a single variable x in which, if updated by one object, if you try to access it with another object, you will see the updated value, right? And it is very much possible that you don't need all the data static. It is legal that you have one variable which is static and other which is not static. It is perfectly fine, right? But since, just for illustration purposes, I have taken only one variable that is static, right? It doesn't mean that all the data in your class must be static. It is perfectly legal that some of the data is static and other data is just like we have been doing previously, right? So since it's slightly tricky, so it's better that I write this program and I show you the output so that you are convinced that it is actually happening like this, right? Let me write the program and then maybe we can discuss your queries. So for this, what I will do is I'll just make a class. Let's call it test. Okay. Something like this. So first, you see, this is the normal way we have some integer, int x, right? If you want to make static, just use the keyword static before this. And since you have a static data member in your class, you also need to initialize it before you create any object, right? So you see, outside the class, I have initialized it with 0. You can initialize it with anything, right? Now I make a constructor in this class. So in the constructor, I'm writing increment the value of x, and I have a function int get x where I simply write return x. Okay, so it's I think exactly the same which we did. Now we go to the main. Okay, and in the main I can write, say, test t1, t2, t3, t4. Okay, I create 4 different objects. Okay, so it means when the constructor is called for t1, x will become 1. For t2, then it will become 2, 3, and 4. And now we can see what is the value of x. So I can write t1 dot get x. And let's call the get function for every object. Okay, so what do we expect? Basically, since the data member is static, so all the calls should print exactly the same thing, which is 4. So I'll share with you the output window. Now you see in the output window, whether you call the function with t1, t2, t3, or t4, we are getting the last value of x, which was 4. Okay, so it means that x is actually shared by all the objects, because when t1 implemented it, t2, t3, t4, the final value was 4, and the same value is shared by all the objects of this class. That is why whether I am calling this function with t1, t2, or t3, or t4, I'm getting the same output because it is shared, right? And one last thing that you see by looking at this program, you must have observed that when you are calling the function getX, so actually the object is not important, right? When I say object is not important, it means whether you call it with T1 or T2 or T4, you get the same output, right? So in such cases, you can also make such a function a static function, just like you have static data. If with this function, suppose I write the keyword static, okay? Now, in order to call a static function, you actually don't need an object. You can call the function only with the name of the class. So now I can call this function with name of the class like this. Of course, you can call it with object. There is no compulsion, right? But if you make a function static in your class by using the keyword static, you can call that function by only using name of the class and scope resolution operator. So you see, when I'm calling this function, we are writing test, scope resolution, and getX function. There is no need to write object. Although if you write object, that is correct. It will not give you an error. But since we discussed in the previous example, object is not important. So you are allowed to call it without object, and now you can see the output, which is 4, right? So it's your choice. You can do it either way. You can make a static function, or you can call it with the object. But if you make it static, the advantage is that you would be able to call this function without the need to make an object, right? And one last important thing is that if you have a static function in your class, in this function you can only access static data of the class, right? For example, if I had another integer which is y, okay, so x is static but y is not static. So since getX is a static function, so in this function I cannot access y, right? For example, I cannot access y because from a you see, this is giving me an error. Why it is giving me an error? Because I am trying to access non-static data from a static function. This is not allowed. This is only one limitation of that, right? So this is slightly a heavy topic, right? But luckily, this is a concept which is not very frequently used. But still, I'll give you a quick summary before we discuss. You can have static data and static functions in your class. Static data is shared by all the objects of a class. If one object is updating, the other objects will see the updated value, right? There is not a separate copy of data for every object, just like we have for non-static data. The second thing is you can also have static functions in the class. You just put the keyword static before name of the function. And if you have to call a static function, you don't need to create object of that class. You can simply write name of the class, scope resolution operator, and you can call this function. But a limitation of this function is that if you make a function static, in that function, you can only access static data of the class. You cannot access non-static data of the class from a static function. Okay, so since we already had a relatively heavier session, so I'll keep things very light in the subsequent discussion, right? Will not be writing any further programs, right? But I'll be telling you something from the perspective of design, right? So no more programs, so just you can relax. And basically, you see, whenever you have to provide solution to a problem, coding or programming, it is a very, very small part of that, right? Means coding is not something that requires very special expertise. If you know the syntax of a language, you can write a program, right? What is more important is actually design. And you will have a complete course on software design. I don't know, maybe it's in software engineering, 4th or 5th semester, right? Where you actually see how you design a solution. So since, although it is not a major part of our course, but since we are studying object-oriented programming, so we should write programs which have a good design, right? So that from the very beginning, you have this habit that rather than just providing any solution, right? Our objective is that we should provide good solutions. And what are good solutions? The solutions which can be reused, the solutions which are scalable, right? Scalable means that if you want to extend it, then you don't have to change a lot of things in your program, right? And there are, of course, some other features as well, which as of today won't make much sense to you. So let's just stick to a couple of, you can say, parameters which I have mentioned, right? So the important thing is that whenever someone will come to you with a problem, right, he will not say, suppose you in your neighborhood, there's a chemist, okay, who has a pharmacy, right? So he says, okay, I have this pharmacy and I want that you make a software for me so that I can keep track of my medicine. When something is out of stock, it should alert me, right? And at the end of the day, I should know how much sales I have made every day, every week, every month, and so on, right? So you see, when someone will give you a problem, he will not ask you Please create a class medicine with an integer data member to store number, with a float to store price, right? Because if someone can provide you with that much information, he or she can himself or herself write the program. The client will always give you a layman description. I have a store, I need to keep track of medicine. I want an alert whenever some medicine is out of stock, and I need a summary of my sales. This is how someone will give you a problem. As a software graduate, computer science graduate, it is your responsibility to decide how many classes you need. What are the attributes in those classes? And what are the functions in those classes, right? So if someone comes to you with this problem, it's not like that you will open a Visual Studio and you will start writing a class. Okay, it is never like that. Since we are presently making small programs, so maybe we do like that. But before writing any single line of code, first you have to design a solution. And if your design is good, there are many tools which can automatically convert your design into source code. Of course, that source code would be only be a skeleton. You will fill the business logic yourself, but still it's a great help, right? So for design, if you remember, in the early days, I told you that normally we use a modeling language which is called UML, Unified Modeling Language. It is not a programming language. It is a language in which you can design your solution, and it's just a visual drawings which help you create your design, and then you can convert your design into a source code, right? Since this is not a course on software engineering, but we are studying classes, so we discussed previously as well how you represent a class in UML, right? So if you remember, we said that for a class you make a rectangle, okay, and which has three parts. The first part has name of the class, for example, say. Then the second class has data, and second part, and the third part has functions. Okay, there's a syntax that, for example, if it's an integer, you can represent it like this, but I'm not telling you, it is in your slides. You can go through it, because I don't want you to confuse this syntax with the syntax of a programming language, right? Because this design is independent of any programming language. You can convert it into C++, Java, Python, or anything, right? Just one note that anything which is private, you represent it with the minus symbol. Anything which is public, you represent it with the plus symbol. Okay, so now this is UML representation of a class. Of course, you will have many classes in your program, not just one class. Okay, so you will have all these classes, and maybe this class is calling some function of this class, or this class is using this class. Since we have not seen that, so I'm not intentionally telling you the names of those relationships, but we'll see them in the subsequent weeks, right? So the idea is that whenever you do an assignment, please make a habit of first making a UML diagram, right? And once you make this UML diagram, there are tools. You give this diagram and you say generate Java code. So it will generate Java code for it, right? Of course, the functions would be blank. There will be no logic, but you will have all the syntax, everything generated, just like our Visual Studio generated a CPP and a header file with empty constructors, right? Just in a similar way, there are tools you can use to generate. You just put your effort in designing, it will automatically generate the source code, and then you can fill those functions with the business logic, right? So this was just an important note that I wanted to make. The next thing for today is that today I'll be uploading, since we are into the fourth week, so I'll just be uploading your first assignment, right? It is not uploaded yet, but I'll just give you some details that what you need to do in that. So let me just open it because it is not presently uploaded. So I'll show you here so that you understand well what is required to be done. Okay, so let me just share it with you. Yes, I hope you can see the PDF file, right? So here it is. Yeah. Okay, so you see, basically it's a very simple assignment. You have two tasks. The first task is that we also did it in the class. So basically in this task, you will be you are provided with this small program which has an integer radius, right? And you have to make two functions, standalone functions, one to compute area and the other to compute circumference of the circle. right? So basically, it means you have to write a structured program. It means no classes, no objects, just what you used to do previously. The second part is that you will convert this program into object-oriented program by making a class circle. Right? For example, you already have the class circle. Now you will have int radius. Now in this class, you will have two functions, one for area and one for circle, right? So if you remember, day one of the semester, we discussed some differences between structured and object-oriented programming, right? When you will write this example, it will actually allow you to better understand those differences. That if you remember, we say all the data is in the main, which is here. You pass the data to the functions which are doing the job, and they are giving you back the value. In object-oriented programming, our focus is on object. So what was the object in this problem? Circle. And object has data as well as functions encapsulated together in a single package that we call a class. Okay, so when you will make functions within the same class, and then you can compare the two, that how both of these solutions are different, right? So it's fairly simple. I hope there should not be any problem. If there's any problem, you can let me know. Just a secondary task is that you will extend the circle class, means the class which you made in task number one, to have some more functionality, right? And what is that additional functionality? Very simple. Instead of just radius, you will add two more integers, x and y, which actually store the center of the circle, right? So basically x, y, and radius. You already have radius. In task two, you will add x, y as well. You will add a parameterized constructor. Very easy, you can do that. Set and get methods, we saw today that for every data member, you will have a set function like set x, set y, and set r. Similarly, get function. So you will have three set functions and three get functions. Right? A function to display the data members, very easy, cout, three cout statements, right? A function enlarge circle, right? What it says, which increases the radius of the circle by a factor passed as input, right? Now, what does it mean? That suppose we want to increase the circle, we want to enlarge the circle, right? So we have a function, maybe like this enlarge circle. If I pass it 2, it should double the radius, right? So it means it is something like radius is radius into whatever you have passed as an argument. Okay, so it should again be very simple. And then two more functions, move horizontal and move vertical, that suppose the center of the circle is 2, 4. If I say move horizontal and I pass 5 as an argument, you just add this 5 to 2, so it should go to 7, 4. Right? So it's just simply you have to add something in x, and similarly when we say move vertical, you have to add something in y, and that something is actually what you pass as an argument, right? So it should be very simple, and I hope there should not be any problem. But still, if you have any problem, you can always pose your query either through Plaza or through email, right?